Today on Cloud Concepts, we will cover the reasons why to use the cloud. Welcome back to the channel. If you haven't looked at our prior video, I urge you to watch that video before you watch this one. Before we begin, let's start with an introduction. Hello, my name is Chris, and welcome back to the channel, Cloud Concepts. The goal of this session is to teach about the benefits of the cloud so you know why it is a great evolution for your business. In the prior video, we gave a technical description of the cloud. This session, we will cover why we would use the cloud. Again, please like, subscribe, and share the content to help the channel grow. Let's start off with some of the prerequisites. We need to understand these concepts before we continue. Let's talk about the client-server model, availability, scalability, and agility. When we talk about the client-server model, this is the foundation of how computer applications function today. The clients are the initiator of a service-related request. The request is transmitted over a computer network. The server fulfills the service request or works with other servers to complete the task. They wait for the request and normally provide a response. So you can see here in this depiction, the client could be you in any case. It could be your laptop, your mobile device, your desktop, and you're making a request. Let's say you're on a website looking for information. Let's get into an example and describe this a little bit in more detail. Here we have our website example. So I'm trying to go to youtube.com, and the first thing that happens is that I put in my browser youtube.com. Well, my browser doesn't really understand where YouTube's content is. So it has to first go and initiate contact with something called a DNS, or a domain name server. The domain name server provides an address for where the content is hosted. So it provides an IP address. This is what we call an IP version 4 address, or IPv4. So we get the information back to where the address is, and then the browser will automatically contact the web server. The web server then, like I said, some servers can become clients, will contact the database server to get, let's say, a list of content that might be interesting for you to watch. From there, the web server provides a response back to your browser, and then your browser needs to fetch some assets from some type of file server or storage server. So for instance, videos, images, they might not reside on the same web server that the web page content's on. So you can see here, our client is our laptop. We have a DNS server, we have a web server, we have a database, and we have some type of storage, web storage. It could be a file server or something. There's many servers to help with this interaction. Let's move forward. Now we want to talk about availability. So if we want to run something like YouTube, we have to think about that service being available, right? So one of the ways that we can make a service available when it's running on hardware is by decoupling the hardware. So let's say if we're running a server that we've talked about in our previous session, one of those big machines that have multiple RAM, multiple CPUs, multiple power sources, right? That's what we call fault tolerant from a hardware perspective, right? But we can expand that by taking some of the elements and separating them for the benefit of service reliability. This is what's called hardware decoupling. So we can take compute, which is the processor, the memory, some storage, and separate it from other components like the actual files, the other components of the workload. So we can separate compute and storage, and then it creates this environment where now service reliability is much higher because we have this high-speed network connecting both components. Normally, in your personal computer, everything's together, and that's fast. But in a data center, we can have these high-speed networks. It's almost like having your computer in that tight space, but it's a very high-speed network, so it maybe introduces a little bit of delay, but not much. The benefits of this decoupling far outreach the disadvantages of the slight delays, and we're talking about like milliseconds or nanoseconds. So with decoupling the compute and the storage, we also create a scenario where we can create redundancy, which means the ability to duplicate. So from the storage perspective, we can duplicate the storage. So every file that's being accessed by the compute or being created, being modified, the storage can be duplicated in another physical hardware. This creates ideal fault tolerance. So if now this hard drive fails, it has been duplicated, not in the same machine, but in another machine on premise in this data center. That scenario creates a increased reliability that your information is going to be available and ready for you. Now, we just talked about availability. So availability is the time that your service is available for you. Now let's move on to high availability. In the next diagram, you're going to see how we can denote high availability architectures, how we can create them. So you can see in the first architecture here, we are operating in a single data center. A zone is represented by a data center or a group of data centers, let's say, and a region is a geographical area. So for this first example, we have 99% availability, which we also call it 2 nines. This means that we have our web server and a database in one, let's say data center or group of data centers. What does that calculate to? Well, 99% availability means it's up 99% of the time, means that the opposite, the downtime, is approximately 3.65 days in a year. So if you can afford your system to go down 3.65 days in a year, then this is a good solution for you. Maybe it's not a critical process, and maybe you can afford that downtime and you just wait for it to be back up. So that's approximately 1%, right? So 99% up, 1% down. Let's talk about our 3 nines architecture, which is 99.9% available. We have one region and we have 2 zones. So that means, let's say we have 2 data centers and they're split by some good distance, right? We have our web servers, and in this scenario, we have a primary database and we have a secondary database. The secondary database is constantly being backed up. So it's a backup of the primary database. So if there's a disturbance in this one data center, the second data center picks up the traffic, and this secondary database becomes the primary. This scenario allows us to reduce our downtime. So we'll have 8.77 of hours of downtime a year, and that translates to 0.1% of downtime overall. Let's talk about the 4 nines architecture. It's 99.99%, which means now we've got 3 zones in this one region. We have our primary, we have our backup, and then we have a backup to a backup, right? So these 3 servers are running, our primary database is getting backed up, and then we also have another backup of our database, which we call a read replica. It helps also offload traffic, read traffic, but for the purpose of this, it's also creating a secondary backup. This translates to a downtime of 52 minutes, 0.6 a year, and that's 0.01% downtime. let's look at our 5 nines architecture. Now you can see something that's really low for downtime, which is 99.999% availability uptime, right? But we've done this by creating 2 regions. So 4 data centers, but the 2 regions are separated by some great distance. Now they could be like in the east coast of the US and west coast of the US, or they could be even a little bit closer, but maybe in 2 different states, right? So we have our primary database in one region, and we have a backup. And then also what happens is we have a primary database in a second region and a backup. And then the 2 primaries are getting synced. So we're having the same data in both regions. What does this create? Well, it creates a really low downtime for the year of approximately 5 minutes. Just think of that, 5 minutes for the entire year, which is 0.001% downtime. So as you can see, how high availability works is by really keeping your service up, right? And reducing that downtime for some type of hardware failure or some things that we don't have full control over. So think of a power failure, internet issues. It could be something even that like a technical issue within your data center, maybe some type of misconfiguration, right? But high availability is that really high percentage of keeping your workloads and your systems running in spite of failures. So let's move on and talk about a component of our systems that we want to monitor and we want to figure out how to adapt for. So let's talk about scalability. What is scalability? Well, it's reacting or changing your workload to meet the future demands and also be able to kind of shrink what you're using to in the lack of demand, right? So we have 2 concepts that we should talk about first. We want to talk about vertical scaling and horizontal scaling. So vertical scaling is a concept where you take your resource and you make it more powerful. You make it bigger, right? So let's say I'm running a server and it manages to do really well serving 100 clients, but something's happening and I'm getting double that, right? So I'm getting 200 clients. So instead of having latency or delays for the client where they're waiting for page loads to happen, what I can do is I can increase the server, maybe more powerful CPUs, more RAM. I can increase that server and make it compatible for that 200 clients that I'm experiencing. That's called vertical scaling. So it's the increase or decrease of the resource size. So in the same respect, I've increased it to 200, and in a few months, something has happened to my business. I'm scaling down, and I want to save costs, and I'm not getting 200 clients anymore. I'm getting maybe 50, so I need to scale down my resource to kind of meet that demand, rather than running at a higher capacity than I really require. Okay, then let's talk about horizontal scaling. So horizontal scaling means that I have a machine that can, let's just say I have a server that's capable of meeting the demands of, let's say, 40 clients, right? And normally on a regular day, I meet the demands of 100 clients. So I have, let's say, I have a server running, but I need more. So I can add more servers to it, right? So I can say, I'm going to run 3 servers because I have 120 clients. And then later in the day, something happens where we run a sale and it gets up to, 160. So I can run 4 servers, right? Maybe 5 servers, 4 servers. And then later in the day, towards the end of the night, it gets down to 40 clients. So I can, turn off some of these servers to kind of accommodate the traffic that I'm experiencing. That's called horizontal scaling. So we increase or decrease the quantity or the number of resources. So I can add more servers or I can reduce them. So instead of increasing the size, I just add a new server, and then I can direct the traffic to the two different servers. And we'll talk about concepts for directing traffic and probably in a future episode. So these are the two types of scaling. So now let's talk about how we can react to situations. So dynamic scaling is a way where we measure our resources. Let's say we look at how our servers reacting to the amount of traffic that's coming through. Maybe it's through network requests or some type of CPU usage. And we say, okay, our CPU usage is high on the server, and then we should be adding more resources to accommodate this traffic. That's what we call dynamic scaling. So we have high traffic, low traffic scenarios. So in this situation, horizontal scaling is ideal for this type of scaling, right? So we have ups and downs. So we can add resources, we can take away resources. Then we have another more predictable type of scaling, which is called scheduled scaling. You know when some event is going to happen, so you're going to predetermine how you're going to react to that. So let's say I run an office and I run software that my staff needs to use, and we operate between 9 to 5. What I could do is I could say, okay, in the morning, I know people need the software, and then in the evening, they're gone home and no one needs the software. So I could start all my servers, let's say at 8:45, right before everyone comes in, so it's ready, and then I can shut them off maybe a little bit after 5, just in case someone has to stay late, around like 6 o'clock. Right? And then this way I can scale my servers based on the demand. I know that people are going to be using them between 9 and 5, so I have them running between 9 and 5, and I can turn them off. Now, this could also be used for some type of marketing event. So you know there's a marketing sale, like for instance, we just passed something called Black Friday, where there's a whole bunch of sales. So what we can do is we say, oh, these holidays, we know that there's more sales coming through on our e-commerce platform. So let's boost up the resources. So we can schedule servers to help in those scenarios. Now, what does this create? Well, it creates a scenario where you have to have some type of planning in place. If you own a data center, you have to purchase the hardware you need, but you have to really predict those peaks, right? In this diagram here, you see some peaks and valleys. So a peak is when the highest traffic is coming in, right? So you really do have to predict what your highest level of traffic is if you don't want to cause a disturbance for your clients, right? So cause any type of slowness for the response to your service that you provide them. So planning is a bit of a hard thing to try to figure out. And then also, now let's say you figured out what those peaks are, and you have your resources and you're ready for those peaks, but maybe most of the time your hardware is just idling, just waiting for those peaks. But when you have hardware idling, you're still paying. You've paid upfront for that hardware, and you're still paying for that hardware to be running for predicting those peaks, right? So these are two concepts of scaling that we have to kind of be aware of because we plan and then we might idle as we're waiting for those peaks to come through. Now let's finally talk about agility. So agility means creating, testing, launching applications that brings business growth in the consistently evolving environment. So think of everything that's changing in technology, and we want to be able to, provide our business the tools they need to grow. Right? That's what technology does. So planning for growth requires a lot of foresight. often restricts our ability to react quickly to change in the market or new business opportunities. So we purchase hardware, that hardware is working perfectly. What do? Oh, we need to upgrade, right? So our data center doesn't really offer us that much agility. We have to plan in advance. We have to purchase. We have to purchase from vendors that might take months, and then once we get it, then we have to go through our setups and everything. So we think about our modern examples here. I want to run a new project, but the current hardware that I have in my data center is there for the growth of my existing business, right? But I want to try something new. I don't have the hardware to try that new project and to see how well it functions in the market, right? I know that there's new technology that's come out, right? There's new hardware, and I want to really try that new hardware because I think it would be beneficial. It would make my service function faster, and I would be able to reduce, let's say, even the footprint in my data centers by upgrading my technology. It's faster, it's energy saving, it has more resiliency to failures, right? But I have to go ahead and make that investment, right? So it's preventing me from being agile and creating and testing and launching new applications. Then I also have technology innovations. Well, what happens if someone's creating some new technology, some type of quantum machine, and I really want to just test to see how I can use that, and maybe my business has an opportunity in there, right? But I'm not agile enough because, again, I have to figure out how to purchase it, set it up. I might even have to bring that's a new environment that they're testing and they're working on. Who do I hire to even maintain that environment, right? So agility can even be slowed with your hardware limitations, your ability to acquire new technology, your ability to look at the evolving technology in the market, some new technologies, right? You won't be able to do all this because if you have to go through this model where you acquire for your data center, and then that time cycle that takes for you to go through that acquisition, can really harm you in terms of agility. So let's now talk about why we would use the cloud. So why use the cloud? First of all, we talked about in our past video, we talked about the upfront costs, but we also talked about it here, even in our last slide, right? So when we have upfront costs, we also have that time that impacts agility that we talked about. But with no upfront costs in the cloud, right, you don't have to have this capital expenditure, this big investment, right? And it also creates a scenario where the cloud offers you instant access to a global infrastructure. So in the high availability slide, we talked about having multiple data centers in different regions. Imagine you having to set that up for yourself, different locations geographically, and then managing your staff there, et cetera, et cetera. Cloud gives you instant access to global infrastructure, regardless of which cloud you select. The other great thing about this is you only use and pay for the capacity required. So in our scalability slide, we talked about the, especially for horizontal scaling, adding more instances, removing the instances. We talked about the planning issues, planning for peaks. Well, in cloud, you really don't have to plan for peaks. You just have to be able to react with scaling. In cloud, you don't even have to idle. If you're running your architecture properly, if you designed it properly, then you can reduce your costs significantly by getting rid of idling. And then lastly, for agility, we can try new technologies without making an investment. Think of you want to activate some type of technology that looks at satellite imagery. Well, we can get access to that through cloud providers. We can access 5G networks through cloud providers. There's so many innovations that cloud providers have that they're offering to us. And then it gives us the opportunity to be more agile and try new things and really work on our business. So let's move forward and talk about some type of deployment models that we can use in the cloud. Now, we already know our current deployment model, which is our data center. So the on-premise is also called a data center, right? Then we have our other core deployment model, which is maybe you have a new business idea and you want to run servers, maybe it's in e-commerce, you can go to the cloud directly and you can run that from beginnings. Your startup, it's a perfect opportunity for startups to reduce their costs. Then we also have a scenario where, let's say you currently have a data center, right? I'm going to give you an example. You have a data center and you're storing a lot of content, but you're running out of storage space. And you say, you know what? I don't want to keep on acquiring this hardware for storage, and I have to keep on planning for more storage. So you create a hybrid scenario where you have your data center and you put some of your backups, you archive into the cloud. That's one scenario. You could also be running some type of application that you run in your data center and in the cloud as a backup, as a failover scenario. So your application stops. Something happens in your data center and you can use the cloud to continue running your operations. That's called a hybrid approach. Now, there's also another approach called multi-cloud. This scenario really helps increase availability. So instead of running your workloads in one cloud provider, you can run it in a second or even a third one. And this gives you a good opportunity. You can run them in different regions on different cloud providers, which really increases your availability of your service. So now let's talk about service models. So when we talk about our data center, there's a lot that we have to manage, right? We have to take care of networking, storage, our servers. And then if you're virtualizing and creating virtual machines in your environment, you would have to manage that. You would have to patch your operating systems, your middleware. So let's say if you're running some type of web server, you have to keep that updated. Your runtime. So if you're running your web server, but let's say you're running some type of PHP application, server-side scripting, you'd have to manage all these components. Your data, obviously, you'd have to keep that safe, encrypted. And then finally, your application, if it's a custom application you're running, or let's just say this website example, this PHP website that you're running, you basically have to take care of all of this. Well, when you come to the cloud, there are three models you can use. You can use this IaaS, which is infrastructure as a service model, which allows you to hand over responsibilities of networking, storage, servers, and virtualization. So you're literally coming to the cloud and saying, I want a server, so like a virtual machine. And then you can choose your operating system. You can load your web server like Apache, Nginx. You can run your PHP. Your data can be encrypted, and you can run your custom web page, right? So that's coming in with the basics. You just want servers, and you're gonna get the architecture from them, but it's all virtualized. The next scenario is you want the cloud provider to manage some of this stuff for you. So you want them to provide a platform. So this is a PaaS model, PaaS, platform as a service model. So they take on top of what they did for infrastructure as a service, now they manage the operating system patching, they manage the middleware for you, and then the runtime. So let's just say, for instance, you want a database, right? And you just want the database to be running for you, and you want some automation and backups and stuff like that, so you don't have to manage it yourself. You can come to the cloud and you can get this type of model, which is PaaS. So now you just have to manage your data and the application. And then finally, we have our last model where everything's managed for you, which is software as a service. So think of this as a solution like your email, right? You don't have to worry about networking, storage, servers, virtualization, the operating system, middleware, runtime, data, or your applications. Everything's taken care of it. You're just coming there for the service that they provide, the software that they provide as a service. So let's wrap up with a quiz. It's quiz time, guys. Type your answers in the comments below. Question number 1. What does availability represent? Question 2. How does vertical and horizontal scaling differ from each other? Question 3. What cloud deployment model still uses your data center? And specifically, it's cloud deployment. So cloud's involved, okay? I look forward to your answers in the chat, and I will see you on the next video. Thank you, everyone.